Assalamu alaikum. This is Dr. Usman Sadiq Paracha, and today we would be having our lecture number 32 of the subject Applied Quantitative Analysis and Practices. Now, in the last lecture, just for the recap, we just had the finalization of how to conduct multiple regression in SPSS. And in that specific case, we had a brief overview of mediation and how we will perform this mediation phenomena. Now, as this is our last lecture, so we would be having an overview of what we have been doing in the previous lecture. Though statistical and analysis or quantitative business analysis is very much focused into the application of statistical techniques in business administration and in business research. Here we have focused on the theoretical aspect and also how to apply that theoretical aspect in real-time business research models, in real-time business companies situation in which a number of different issues arise, and then we have to tackle those issues first by having maximum information about the phenomenon, because that's the first step. And once we do get the maximum information in the form of data from the organization, then our second step is to analyze, to see the data, the way the data is presented and what's the nature of this data. And after analyzing it, then we are able to make some informed decision about how to tackle the situation. So in any kind of situation and issue in business organization, this has become very much vital that we get factual information from the field of study, and once we get that, we observe it in detail, we try to measure it in detail, and then we analyze it in detail, and then after that, based on that analysis of factual information, then we are able to at least make an informed decision, a more better decision, instead of making decision based on opinions. So from that aspect, this field is very much important, and it's very relative that a detailed practice of such kind of methodology be made so that a student is able to at least tackle the analytics of business when you are basically encountering a real-time job. So in this case, going through the previous lectures, basically we started with how to define and collect the data, what's the nature of data. We already know that data is the information which is collected from various sources, and here basically the definition and the collection data is the very first stage, in which then we start making our movement towards more better decisions. And in this case, the very basics which we discussed about was regarding two basic variables. One was categorical variable, the other was numerical variable. And again, we know that categorical variable comprises of values like yes and no, and basically we are dealing with qualitative type variables which are also having categories. Then we have got numerical variables, in which we have got basically two types. One was a discrete variable comprising of counting process, and continuous variable arising from measuring process. So based on that, basically we have got two major types, which you can see here: categorical and numerical. In categorical, as we have seen here, that the examples are marital status versus a political party. We are basically dealing with categories. And in case of numerical, though, we are coming into more explained data, more sophisticated data, and in this case, in case of discrete data, we are dealing with counted items. Then we are dealing with continuous variable or continuous type, in which we have got some very myriad characteristics which are basically given in much more detail than the data in other categories. So then we went through the explanation of what are the different levels of measurement here. What do we mean by nominal scale? As nominal scale here, you can see is dealing with categories. So here basically nominal scale is more related to the categorical variables, and we have seen already that the categories which are already written here, like this one, or the three categories related to type of investment. Again, all this stuff basically is related to nominal scale. In other words, categorical data is defined by nominal scale. And again, as we have tackled this thing in SPSS, we have seen that in SPSS software, this kind of data is also nominated with nominal scale here. So then we had a discussion on what is an ordinal scale, and again, in this case, the ranking is implied, as you can see the example here and here as well. So basically, in this kind of ranking, there is a certain order. That's why such kind of a scale is termed as ordinal scale here. And ordinal scale, again, in software in SPSS is also termed as ordinal, and the various examples were discussed with you here, like as shown in the screen. So then we have got another one which is termed as interval scale. And in this case, we can see that the difference between measurement is quite a meaningful quantity, but they don't have an absolute point here. Likewise, in ratio scale, we are also dealing with a meaningful quantity, but then we have got a true 0 point. So normally in SPSS, as we have discussed before, that both the scales are basically represented by scale only, and the option which is presented there is just represented by scale. So then we had a discussion on the sources of data. What are the sources from which such kind of data is collected? Primarily there are two types. One is primary source and the other is secondary source. In this case, the primary source is basically the data which is the observed data, as it is collected from an experiment, from a survey. And in secondary source, basically here we are taking the source basically lies in published data, and based on that basically we try to make some conclusions. So these sources of data are of quite importance here, but it depends that what kind of situation you are dealing with, and based on that you select the source. Then we had a discussion about what's the difference between population and sample. As in business research, we have seen that we are unable to collect the responses from all the respondents in any organization or a group of organizations. So we claim such a collection of organization as a target, in which all the individuals in there are basically termed as population. Now in that case, we do have to select a portion which is able to represent the whole population. So it depends a lot how that portion, or also such a portion is termed as sample, how this sample is selected from that population based on the methodology through which that sample is collected. is then basically very much I would say helpful in determining that whether this sample will represent the whole population or not. So the main thing is that it's not easy or possible to collect the information from the whole population here, and we do have to basically take a sample. But again, we have to basically follow the methodology of sample in a very meaningful way, so that the sample is the true representative of the population. So after then we had a discussion on what are the different types of sample, and as you can see that there are two primary types. One is the non-probability type of samples, and then the other is probability type of sample. Here you can see the judgment one, in which the sample is selected based on judgment, and then we have got convenience sampling. Basically this in this sample is collected not based on a certain pattern, but just on the matter of how accessible the respondents are to the main researchers. So then we have got the other types like simple random sampling, systematic sampling, stratified, and cluster. And in this case, simple random basically terms the sampling as the one in which we randomly pick our respondents by developing a sampling frame. And then we also have another type which is systematic, though the nature is random, but we try to select our respondents after a certain time period, after a certain number of individuals in the sampling frame, so that the selection of the individual from the sampling frame becomes kind of systematic. So then we had a discussion on stratified sampling, how we can make the strata different, and then again in cluster we were dealing with clusters. Then after going through different data collection and how to basically see the types of samples, again it is worth mentioning here that the sample types basically are selected based on the nature of the issue which an organization is dealing with. So based on that, we had a discussion on one of the very important tool which is used in collecting the data, and that is called survey. And we have to basically decide that how to calculate or evaluate the worthiness of the survey. So basically we have to focus on what's the purpose of the survey here, and is the survey based on probability sampling. And then we have got another 4 important error issues. We have to see whether the survey is having such kind of errors or not. This specific tool is discussed here specifically because this is the most common tool which is used in business research issues, in business organizational issues, and therefore the importance of this tool becomes very much evident here. Now, while dealing with the errors which we have discussed, whether we have got the coverage error, have we selected the appropriate frame or not, whether we are dealing with the follow-up or not, or whether we have posed good selections, or whether we have got sampling error or not, which basically does exist. We cannot reduce it, but we have to mention it. So we just have a visual display of the kind of errors which are of primary importance while evaluating the survey. And in this case you can see that in coverage error there's a chance that important respondents can be excluded from survey. Then whether we have to go on for follow-up analysis or not, or follow-up for non-responses. That is why in order to tackle that, we have to basically consider only those surveys in which the survey was already filled fully in the first instance, and we don't have to follow up after that in order to avoid such kind of non-response error. Then we have got sampling error, which basically differs and from sample to sample, and there are very limited means to control it. Then After that, we have got another issue regarding the measurement error, whether we are posing the right kind of questions in front of the respondent or not. So based on this thing, after that, we had a discussion on how to organize and visualize the variables, because once we have collected the data through survey and any other tool, then our major concern becomes is that how to organize it properly and how to present it properly. So organizing of such kind of variables which have been collected from the field is of primary importance to us. So we had a discussion on what's the type and how different types of variables can be organized and presented, and we had a discussion on what is the dealing with the categorical data, how we are to represent one categorical variable, and in this case we had a discussion that basically summary table is one of the primary tools to be used for display of categorical variable. Then we had a discussion on how to present two categorical variables here, and in this case we had a discussion about the efficiency of contingency table in this case. And then we also had a discussion on how to tackle a real-time problem through contingency table and how hidden facts can be presented through contingency table as well. This is just an example of how contingency table is presented, how very detailed information is presented in this method, and then we can have a detailed overlook of how to judge the data in this case. So in this case again we had a discussion on how time trends or past trends data can be presented and how they have to be viewed, and how such kind of data which is very much visible here in the form of a simple trend line can be explained more through contingency table. And we basically had a detailed discussion on it in SPSS, and we displayed the result of the same info in a way that some critical info was more evident in contingency table as well. So then after that we had a discussion on frequency distribution and how frequency distribution is one of the very most important tools which gives us a good display of the information in the data. So this is kind of a summary table, and again we are dealing with class groupings, and then we have got boundaries here as well, and again we have the terminology regarding number of classes and width of a class interval. Again, frequency distribution is one of the most common method used and is the most effective way of displaying the nature of data and the trend of the data, and its display basically gives us some very vital information which other graphical methods do not. So then we had a discussion on how to further visualize the data in this case for categorical data, and we had demonstrated that the summary table for one variable can be represented in the form of a bar chart or a pie chart, and also for contingency table we can also use side-by-side chart. Now these methods are basically displayed very much effectively in SPSS using the chart option, and we had a practice session on that, and this was very much evident that SPSS is very much effective in displaying such kind of information. Then we had a detailed discussion on the numerical data and its display, and in this case we did come to know about the ordered array and frequency distribution and cumulative distribution, and in this case the few methods which are used to display information about such kind of data are stem and leaf display, histogram, polygon, and OGIF. However, here histogram is of more importance here, reason being so that it represents frequency distribution, and that makes histogram one of the most essential and effective way of presenting the data. So that's why this kind of tool is mostly used in presenting data in business organization. Then this is the typical example of the histogram we had discussion about, and in this case you can see that number of students about and the data regarding specific values is presented effectively through a histogram, and that's why we had also practiced it in SPSS. It's very much effective in visualization of such kind of data, and that's why it's mostly used in business organization. Another two important tools which we have discussed before to represent two numerical variables is scatter plot and time series plot. And again, in scatter plot, as you can see here, we displayed that example in which the two variables are basically plotted on x-axis and y-axis respectively, and then based on that these two variables are plotted here to see if we can track some kind of pattern, some kind of visualization which would help us in making a concrete conclusion that whether there is some kind of relationship between these variables or not. So that's why scatter plot is very much used first to have an overview of the nature of relationship between any two variables. Again, we can use more than two variables, but the issue is that the more variables we put in the scatter plot, the more confusing it becomes. Ideally, it is important that we should better prefer the scatter plot for the display of result for two variables. Then we had discussed about time series plotting, as you can see here, that as how time series is represented here and the values which are occurring in a certain period of time and with respect to time are displayed here in the form of a graph which basically give us a very fair idea of the nature of data. Again, we displayed this and had a discussion on this on a practical example in terms of results which are collected from a district and how those results are basically displayed here effectively. Then we had a discussion on the guidelines on how to basically avoid this obscuring of data, and again this is very important that we should avoid the chart junk, and then the simplest visualization can help us a lot in giving us the desired results. Likewise, we had a discussion on to label all the axes, and then again we had to basically use a constant scale, and then the scale for each axis should be mentioned, and again the scale should be started from 0. So these are the general guidelines, and we also discussed their implications on how basically they can affect us. Then we had a discussion regarding the numerical descriptive measures, which are a very important lot, and in this case you can see that the summary definitions of the three most important concepts in numerical descriptive measures were discussed regarding central tendency, variation, and shape. Now, central tendency basically deals with how to what extent the data values are grouping around a central value, whereas the variation is the dispersion of that data. Shape basically deals with the distribution of those values, and we basically have a visualization of variation of data in this case. So based on this, we had three most important measures of central tendency discussion, and these were including mean. Again, we had a discussion about mean, how it's the common measure of central tendency, but we did display that mean is not effective in giving us the whole information about the data. Likewise, in case of median, we also discussed about this regarding the middle value, but again we discussed how it may not also give us the complete information about the data in this case. In case of mode, we had the discussion that it's a repeated value. Again, it is not that much effective in giving us complete information about the data as well, and therefore we have to rely on other measures as well to report the data. So this is a summary of the central tendency measures which we discussed, and it is pretty much evident. The geometric mean, again, to track the rate of change is used. All the four effective methods are good enough in their own sense, but this must be kept in mind that only one method cannot be used to get effective information about the nature of data. So we have to rely on all these measures in this case. Again, another important issue is related to measures of variation. And in this case, we can see that there are four most important ones. The one is the range, the second is variance, then we have got standard deviation and coefficient of variation here. Now, these are the real true measures which give us the real-time information about the nature of data and how much the data is spread around its mean. So basically, this is just the example of how basically the data is spread, and this type of display is very much vital in explaining the variance, the standard deviation here, or even coefficient of variation. So basically, measures of variation, again, we have discussed different measures. Range is important as it relates to the difference between largest and smallest value. And again, in this case, we can see that it's not that much effective in explaining the true characteristics of data. So basically, this is just the visualization of how range can be misleading as well. And in this case, then we had detailed discussion about what's the variance and what's the specific formula for variance, what does that formula represents here, and how it can be calculated. The sample variance then leads to another most important measure of variation, which is termed as standard deviation. Again, it's the square root of the variance, and it is having the same units as the original data here. So the sample standard deviation is portrayed here. Again, in this case, you can see that the comparing of standard deviation basically gives us an idea that it is a very effective tool to explain the whole characteristics of data. That's why this is one measure which is very much commonly used in displaying the information. So coming to the visualization, you can see how we can have the same mean but different standard deviation, and what does those different standard deviation measure represent. So there are larger standard deviation which is represented by more flatter curve, and then we have got a more higher curve for showing smaller standard deviation. So basically, the visualization gives us a very clear-cut idea of what's the importance of standard deviation here, and based on that, some important decisions can be made. Then we had a discussion on z-scores, and basically we had analyzed that what is a z-score, and basically it's the number of standard deviation or data value is from the mean. Z-value is again a very much effective tool which has been used constantly in the data analysis, and based on these z-scores, therefore, we can compare these values across the board among different data sets. So its effectiveness is portrayed in different ways, and from here we can clearly see that z-values less than 3 or greater than 3 are termed to be outliers, so we can locate extreme values through this methodology, and therefore z-score value importance is very much evident from here. Then we are dealing with another graphical interpretation in which we are dealing with skewness, and this diagram gives us the nature of the data, basically whether the data is left skewed or whether it's symmetric or not, or whether it's rightly skewed or not. So the diagrammatic explanation is given here, and we can see that the left skewed is explained when mean is less than median of the data set, and you can see it graphically how it is presented here. So based on that, This is pretty much vital that these three different types give us the nature of the shape of distribution, which further helps us in making important conclusions. The other important case we discussed was related to quartile measures, and in this case you can see that the data was basically divided into 4 equal portions, and each portion is termed as the quartile, and here we see how these portions have been divided and what's the interpretation of these quartiles. So basically there are first quartile, second and third quartile, and based on that important further conclusions can be made. Here we had discussion on what's the interquartile range, and basically this is the distance between Q1 and Q3, and that's the place where most of the data needs to be there. So basically the direction of this main interquartile range gives us a very fair idea of where the data is trending and where is the data tilting. So for explaining such kind of thing, we basically use the tool of box plot, and box plot is again a very effective way of graphically showing us the trend of the data and where the data is lying. So we basically had a discussion on that as well. The other important rule is related to the empirical rule, and this is related to the fact that 68% of the data normally will lie in between 1 standard deviation of the mean, provided we have got normal distribution. So this is a very important case here, because this gives us a very important lead to how to tackle our future problems. Then further extension of the empirical rule also represent that 95% of the data will lie within 2 standard deviations, whereas 99.7% data lies within 3 standard deviations. So coming to the other important issue, basically the issue we discussed was related to covariance. Now in covariance, basically we were trying to measure the strength of the relationship between 2 numerical variables, and the formula was discussed in detail. Again, this is worth mentioning that it would give us the strength of relationship, but it cannot tell us the direction of the relationship. So based on that, covariance is again one of the initial tools which is used to give us vital information about the nature of relationship between any 2 kind of variables. So then further extension of covariance is the coefficient of correlation, and again it's the same thing. It represents the relative strength of the relationship between 2 variables, and the formula is displayed here. We have already discussed it before. However, there is a certain feature related to coefficient of correlation, and here it's unit free. We have got certain scale which helps us a lot in determining that what is the stronger relationship and what is the weaker relationship benchmark, basically in this kind of determination of coefficient. So based on that, we also know that this is unit free, so it can be compared across the board. Then we had display of the different kind of representation of coefficient of correlation, how they are displayed and how different values are portraying these different kind of relationships in correlation. And as you can see here that in this case R is -1 in one diagram and 1 -6. So how these different directions are portrayed here effectively through a scatter plot. Then we had a discussion on the application of SPSS of these concepts, and basically we learned how to go through the menu bar, how to define the variables, so how to define their fields, how to basically put the data there, how to do data coding, and after that how to generate these descriptive analysis from SPSS. So after going through these applications, we went through the main issue related to correlation and causality, and we had a discussion on what's the third variable issue, how it impacts the relationship, correlationship within two variables here, and how the direction of causality is playing a part here. So we also have discussion about the Pearson correlation, and again the other two types, which are termed as Spearman's rho and Kendall's tau, and where and when they are needed. Based on that, another important phenomena which we discussed in detail was related to partial correlation, and as how partial correlation is defined, and it basically measures the relationship between two variables while controlling for the effect of a third variable. So basically partial correlation is very much effective in our further future analysis. Based on that, we did have a discussion about an example in which partial correlation was exchanged by taking into account two variables' relationship within each other, and how a third variable intervenes, and how we can explain graphically the variances accounted by these three variables which are joined together, and how to basically calculate exact correlation in such a situation. Then we had a discussion on normal distribution, what is normal distribution and why is it necessary. Again, we had a discussion on the nature of variables here. One is the discrete variable and the other is continuous, and how they are measured. Then we showed them graphically how they are showing that, and then basically the concept lies in the diagram in which the bell curve is made, and how mean, mode, median basically are equal in such a symmetry. Based on that, how the spread is determined and how the location is determined by the mean. So basically this spread is giving us a very detailed idea about the normal distribution. After going through that, we had discussed about what's the nature of this mean, and what's the nature of standard deviation here, how the mean shifts and how it will affect the distribution curve, and how when the standard deviation changes, how that will affect the normal distribution shape. Based on that, we also had a discussion on the z-values, and basically how z-values can be traced in the same normal distribution curve, and how we can assess them, where the positive z-values will lie and where the negative z-values will lie. Based on that, the most important concept regarding normal distribution was discussed, and that was basically to find out the probability of occurrence of any value, and basically that is calculated by measuring the area under the curve. So here basically you can see the concept which is shown here, and we discussed in detail there how to basically follow up this probability concept using normal distribution curve. So this was the distribution of the probability areas which basically divide the curve, and here you can see how the probability of total curve is 1, and then we have got 0.5 probability on both ends of this curve. Then we had a discussion about how to represent z-values and how to find out the probability of a certain occurrence of a value using this distribution curve and using this standardized normal table. So based on that, we went through many examples, one of which is shown in front of you. And then we discussed how to basically track the value of this probability through the table which is given to us, and also which is termed as standardized normal table. And we had a discussion on how to measure the z-value from the such tables. Then we had a discussion on how to go through the general procedure for finding normal probabilities, and in this case you can see how we drew the normal curve for the problem, and then how we have to first translate the x values to z values, and then we can use the standardized normal table to go through our z values. So basically normality of data is evaluated through this normal curve, and again they should be bell-shaped, and again this is vital that empirical rule is applied. Then we have got the evaluation regarding how to evaluate normality. In this case we can use the charts and graphs, and then we can use descriptive summary measures to effectively measure these different kind of normality issues with a certain data. And likewise, the most important tool which is used to assess the normal distribution is normal probability plot. We have discussed this in SPSS as well, that normal probability plot is displayed in order to give us assessment of the normality of a certain data. So in this case, the observed data values are plotted along with the standardized normal quantile values, and then we see whether we are dealing with a straight line. So here you can see this was a typical example which we went through in previous lectures, and basically how and when they are termed as linear and when they cannot be termed as linear. Then after that we had a discussion about building models. The main thing was that how a real-time world's phenomena is translated into a statistical model, and we already know that ideally it's not possible to translate the exact situation in an exact model. So we may also have to basically omit many details, because ideally not all the details can be included in the model. So in this case we have to assess whether the model is of poor fit or moderate fit or even a good fit, but ideal fit is not possible. Then we had a discussion about the process for model formulation, how the model is formulated, and in this case you can see that initial observation is made through a research question, how then we generate a theory, and then based on that how hypotheses are made. Based on that then we identify variables, which you can see here, and it's pretty much evident here that identification of variables, once it's done, then we can collect the data and measure the variables. So once the variables are measured, then we can analyze the data and try the appropriate technique in order to assess the fit of the model. So based on that we had a discussion about what are the theories and how we generate theories. Based on this thing, what is a hypothesis? Basically this is a prediction from a theory which we make, and we try to test such hypothesis whether our prediction are true or not. So then again the falsification does portray the act of disproving a theory or hypothesis. So basically we just had a discussion on what's the standard hypothesis criteria. What are we dealing with? We are dealing with independent variables and dependent variables, and basically we try to find out the relationship between these two, and also in order to do that we have to formulate a formal hypothesis. So based on that we just had an example of a certain hypothesis and how we have to basically derive the various variables from such hypothesis. Then again we had a discussion about the population mean and proportion and how they are involved in determining a hypothesis. In this example basically we had a certain number of options available, and in which we had to derive the hypothesis based on that. So we went through the various examples. Then we were introduced to basic types of hypothesis. One was null hypothesis, and in which basically we tried to test a specific parameter for basically a population, and how this is done. Then there were certain rules which are applicable for null hypothesis, and then it was termed as important when we can accept or reject them. Likewise we went through the alternative hypothesis and how alternative hypothesis is opposite, and what statements are required to basically state the alternative hypothesis. Then we had a discussion about the critical values and the test statistics which are important in determining these hypotheses. and how these test statistics are important in helping us in deciding whether we have to accept a null hypothesis or reject hypothesis. So these are the critical regions which we had discussed about, and then the region of non-rejection and rejection, and these values vary depending upon the nature of test which is deployed there. Now the nature of test basically gives us the relative idea. Then again we have got certain possible hypothesis outcomes which can be troublesome as well, and you can see here that the actual situation which is displayed here, and then we have got another situation in which we may not be following the right type. Basically the decision here regarding do not reject H0, and then what kind of error this can lead to. Then in this case we are also dealing with type 1 error and type 2 error. So in this case we detect what kind of error basically we are committing. At a time both errors cannot occur at the same time, so basically we have to tackle these situations separately. Based on that, then again, what are the errors which may happen, and basically we have discussed this in detail here, that confidence coefficient basically is the probability of not rejecting H0 when it's true. So regarding that, what's the confidence interval, how we can calculate the power of a statistical test, and basically how it is instrumental in giving us probability for rejecting H0 when it's false. So then we have discussion about what are the type 1 and type 2 error relationship, and when type 1 error is there and when type 2 error is there in this case. Going through these different types, then we had discussed about the factors which affect type 2 error and how they impact this. So likewise we also had a discussion regarding level of significance and what is the rejection region in case of a two-tailed test and how it does affect us. Based on that, the concept of p-value was of vital importance, because p-value is the smallest value of alpha for which H0 is rejected, and that is why p-value is reported everywhere, and the rejection or acceptance of any hypothesis is dependent upon the p-values and its significance. So we also discussed about hypothesis test, if we have got standard deviation known and unknown, and when we have to apply z-test and d-test. Based on that, what are the assumptions for normal distribution which should be strictly followed, and we discussed about additivity, linearity, normality, homogeneous of variance, independence of errors. So how we have to test these assumptions were discussed in detail, but while we are basically assessing these assumptions, this is important that we have to reduce the bias. So what are the steps which can be taken to reduce such kind of bias? So we discussed about trimming the data, winsorizing, analyzing with robust methods, and transforming the data. So based on that, these methods we focused on how to reduce the bias. Then was the case was regarding data transformation, which was more important, and how different methods like log transformation, square root transformation, reciprocal transformation can be used to transform the data in this case. So these are the different examples which we went through, log transformation or square root transformation, how they are effective. Then we have reciprocal transformation here, like regarding before and after that. However, we can disturb a normal data and can end up with a data which is not required at all, as it is seen here in the screen. Then whether we should transform the data or not was discussed in detail, and there are certain conditions for that, as we discussed before. And in this case, then we went on to discuss the reliability. What is reliability and how to measure the results and produce the same results under the same conditions. Then the tool which is used to test the reliability, and that's termed as Cronbach alpha. and how this Cronbach-Alpha's rules are used for detecting reliability, and how we calculate it through SPSS was displayed here in detail. Then again, what's the interpretation of the scale of reliability? This was discussed in detail here, and what kind of score here is important, and in what cases we will look for high reliability, good reliability, acceptance reliability, and marginal reliability. Then we discussed about the validity issue and why content validity and construct validity are important to determine whether the instrument is really measuring which we want to measure. And based on that, we were introduced with the topic termed as exploratory factor analysis. And what's the definition and how basically we use it? Basically we use to identify a structure of variables within a group of variables and how to form groups within them. So while grouping between them, we have discussed how basically the various techniques are used in exploratory factor analysis, and then we had a discussion about what's the difference between exploratory and confirmatory factor analysis and why we use these two. Again, in latest techniques, we can use both of them, first to explore the structure and then to confirm the structure. So then we had a discussion about what is simple linear regression, why it is used, and therefore what's the difference between correlation and regression. In regression, basically we have come to know about the causal effect, which we cannot find out through correlation analysis. So we went through the terminology, what is the independent variable, what is the dependent variable here, and how we can basically use them to detect the relationship between that. In this case, we also discussed about the main equation and what role does this equation play in detecting the relationship between any two variables. So you can see here that how basically beta 1 and beta naught are measured and used to know what's the nature of relationship and the impact of the independent variable on dependent variable in this case. Then we had a very detailed analysis of what's the phenomena behind simple regression model and how we can visually explain the different values and the concepts in simple linear regression model. Based on that, again, how these values were calculated for the sample as well, and based on that, what are the different methods which are used in simple linear regression. Now, least square method is the common method which is used, but again, this kind of method also has got its own discrepancies. So how is this possible to remove these discrepancies was discussed. Then another very important concept is regarding measures of variation and how total sum of squares or regression sum of squares and error sum of squares are calculated, and based on that how we explain the variation and how we explain the unexplained variation here. Based on that, this is also vital how basically these concepts are displayed graphically and what interpretation we have from such kind of measures of variation. So based on this thing, we basically discussed how we can calculate the coefficient of determination, which basically gives us the strength of relationship between two variables. So this whole value of R square and this concept is based on these measures of variation, which makes such concept very important for us. Then how these different relationships can be displayed here, and we have seen that how we display weaker relationship and how stronger relationships are depicted here. Based on that, then if we don't have any relationship, how we will depict this in linear regression visualization graphs. Then we discussed about the standard error of estimate, what do we mean by that, and what the small value of standard error has meaning in simple linear regression model and its diagram. As you can see here, how it's evident here. So how can we compare them? Then we had a discussion regarding inference about the slope, how change in unit of one independent variable can have impact on the dependent variable that is basically detected from slope. Also, we have to basically see whether, as we are taking samples, so we follow the hypothesis approach to see whether there is a relationship or not. Then F-test statistic is also used for significance, and basically it is used to test the significance of the whole model and how much valid is the whole model in this case. So then is the important issue regarding the assumptions for regression, how basically we are to use linearity, independence of errors, normality of error, and equal variance. And basically, in order to do that, we do follow residual analysis, which we have discussed earlier as well. So residual analysis is of primary importance, and it gives us a true picture of how much validated is the regression model which we are trying to run. So then we had a discussion on confidence interval estimation, how to calculate that, what's the point estimate, and then how to find out lower confidence limit and upper one, and in this case how we can represent the population parameter and statistic parameter here. Then basically how we are to calculate the interval estimate and point estimate, and why we need to calculate confidence interval. So basically this is the range of values which gives us a fair idea of where our sample values will be lying, and then how much confident basically we can be in determining that our mean is lying between any two specific values. So in order to do that, confidence interval estimate is of vital importance. So there are again discrepancies in regression analysis which we discussed in detail, and basically there are many issues like extrapolating, how we can use model without knowledge of the subject matter, and then what if our assumptions are violated, so what would be its impact on us, then what would be the result of lack of awareness in this case. Then we had gone through the application of a model, a real-time model which is derived, and how we are to test our simple linear regression in SPSS in this case. Then we had a discussion on what is the multiple regression, how basically it is different from simple linear regression, and how we can use it to predict the values from several variables. Then we had a discussion on multiple regression as an equation, how this equation is presented, and as you can see here that we basically extend the equation here, and in this case the rest of the values are related to the other variable values here. So basically the B naught basically is interpretation is given, what is the beta value, how it is termed as intercept, and why is it important. Then what's the implication of beta 1 value, beta 2, and beta n, and how they are important in this case. Then before applying for multiple regression, this is important that we consider the sample size, because three aspects impact the result of multiple regression. One is the sample size, the other number of independent variables which are being used, and then what is the significance level of such kind of variables. And this gives us the surety that to what extent our R-square value can be assessed more accurately. Then there are various methodologies for pursuing model fit in multiple regression, and we discussed those in detail. And in this case we have discussed three primary methods. One is hierarchical, the other is forced entry, the third is stepwise. So each method has got its own advantages and disadvantages, and basically in this case in hierarchy we are entering the values in a certain order. In forced entry we have basically all predictors entered simultaneously, and in stepwise we use semi-partial correlation to see which predictor is to be entered first. Then how to report this model, because calculation is easy, but how we will report this model effectively. So we discussed about that in detail, and how we have to make relevant columns, and then how to assess such kind of values. Then or another issue is how well this model will fit the data. So basically here we have to assess the ways through which we have to measure the accuracy of model, and one is the residual statistics, the second is influential statistics. Both have got their own pros and cons, but basically these methods are used to know whether our model fit is accurate or not. So basically these are the very straightforward assumptions which you follow. One is variable type, second non-zero variance, then linearity and independence. But the thing is that they have to be tested quite meticulously through certain tools. Then there are some more technical assumptions which are related to multicollinearity, and again this relates to the fact that predictors should not be related to each other. Then we have got for each value of predictors the variance of the error term should be consistent and constant, and then we have got independence error as well. So in these cases we have to basically take care of the fact that these assumptions are met, otherwise our whole exercise of going through this multiple regression step will go in vain. Then we have got the issue regarding outliers and residuals, why standardized residuals are important in identifying abnormal values, and based on that how we can follow the influential cases, how we can track them through adjusted predicted value. Then we have got another tool termed as df-fit and deleted residuals, also termed as studentized residuals, how we can basically use them to track these abnormal values. So we took a practical model, as you can see here, in the name of HPWS, and we then ran practical analysis in SPSS in order to show how it is done and how we can address the questions we have discussed before. Then we had a discussion regarding mediation, which is another important phenomena which occurs in regression, and in which basically the situation between two variables is explained by a third variable which may exist in between these two. So the concept here is very much clear through these examples and through these slides, and here you can see the single relationship is predicted, and when is the mediator relationship is predicted here. So based on that, what's the role of mediator here, and what conditions do we follow in order to test the mediation? And in this case we can see that Barron and Kenny is the most sought out case here, which is used, its conditions are used to test the model. Again, we cannot run regression in one go. We have to basically use stepwise approach, as there are limitations in regression as well. So based on that, there are certain conditions which have to be measured, and based on these conditions the predictor must be significantly related to outcome variable. Again, the predictor should be related to mediator as well, and the third is that the mediator should be related to outcome variable. The predictor variable must predict the outcome variable in a certain way so that we can detect the terms of mediation here. So there are certain limitations of this mediation phenomena here as well, and in this case basically we do try to look for a change in significance which can lead to all or nothing thinking. So p-value is encourageable here. Based on these limitations, this is very much vital that they should be kept in view while assessing the mediation. So basically this was the whole aspect which was important while assessing our quantitative business analysis in an organization, and this is pretty much vital that we have a 360-degree review of all the nature of data which is used. Based on that, all these methods which have been discussed in detail should be followed rigorously so that we can come to some concrete conclusion and help our organization in developing more effective tools for further creativity and innovation as well. So based on these, this was the end of our class. I hope you have understood the topics which we have discussed in detail. Thank you so much. Allah Hafiz.